Hello student. Now we continue to find the length of the build of cross build drive. In last class we have discussed about that length of open build drive, length of build of the open build drive. So so we can find the length of like previous length of welt. Okay, of a cross build drive. That's great. So it's we can find previously. So we have already discussed that in the my previous lecture how to find the length of a build drive. So this is equal to arc JAE फिर EF, then arc AF KH and HG. This will be the length of cross belt drive. So if we are able to find this, then we can find the length of the belt. So in the last we have told we have divided in two parts and just double it. So here we can find the JE arc JE plus this length EF, and then this arc, then this double. So we will get the length of the cross belt drive. Okay, the center distance between both pulley is that X, and the R1 is the radius of the big one, and R2 is the radius of a small pulley. Okay. So this must be X. We can correct it. Okay, so great. So this distance between the center distance X, so for the calculation purpose we have we extend this length up to here, and parallel to EF we project the O to M. So so now we can say that we have already given the length of arc here, R G J E plus EF plus arc F K H plus HG, and in other term we can say the 2 times of arc JE plus EF plus plus F, this FK. Understood? So this in which but is 2 times. Okay, then how find the value of sine alpha? That is simply sine alpha, that like a previous sine alpha is will be the O1 this O1 M upon O1 and O2. ठीक है, we can find out. Okay, that's great. So now the O1 M we can write the O1 M O1 E plus EM. We can write here O1 plus E1, where O1 is equal to R1 and O2 is equal to this EM is equal to the R2. So this relation become the R1 plus R2 upon X, where O1 and O2 is the center distance between the two pulley. So sine alpha will be this. So we since alpha is very small, therefore the sine alpha is equal to alpha R1 plus R2 upon X, and arc JE, arc this JE, it will be this angle pi by 2 plus alpha and the radius of this pulley. So this become R1 plus pi by 2 plus alpha. Similarly the arc FK, this FK, similar the pi by this angle is a pi by and this plus alpha. So this angle become similarly R2 pi by 2 plus alpha. Then now find the EF, that this EF, that's EF is equal to the O2 M. So we go for this triangle O1 O2 and M. From this triangle we can find the value of EF, then it will be from that triangle O1 O2 ka square minus O1 ka square, and O1 O2 is, you know that O1 O2 is it X distance between the pulley X square, then and O1 this O1 is R1 plus R2. So now this relation become like this, and by solving this by using the binomial theorem, so we can write like this, but there is a must be a square. Okay, great. Okay, so now this will be become like this. So just substitute the whole value in the what we have written here in the equation number 1. So In equation number 1, just put the value, since so this become like this, and just multiply the whole term by this 2, so this become this. And now just put the value of alpha. So we can, after putting that value, so this relation we can rewrite like this. So now, so relation length of the belt in the cross belt drive will be pi x1 plus x2 plus 2x r1 plus r2 का whole square upon x, and angle of contact of smaller pulley and angle of contact of larger pulley, that both are the same. So you can see that angle of contact means this is called from E to Z, this is called angle of contact. So this is this angle will be pi, okay, and this is plus 2 alpha similarly here. So angle of contact for both pulleys given here. So thank you so much dear student for listening this lecture.